Okay, so let's talk about Newton's method. And yes, this is Sir Isaac Newton, who has done a bunch of things for both math and science. And he was thinking that, well, this linear approximation thing could be used to help find zeros of a function. Now, this function that's graphed here, you can clearly see that it crosses the x-axis at -1 and 1. But let's say it crossed at a number that was a little tougher to identify and one that we can't solve for analytically, and we want to figure out where exactly it crosses. It's some irrational number that is tough to determine with our certain techniques. For instance, we know linear functions. We can solve easily. Quadratic functions we can solve easily using the quadratic formula. But things like cubics, we don't have a general form to solve every cubic under the sun, or any quartic or quintic or any higher order polynomial. So Newton came up with this method. He thought, well, if I pick a point, any x value, and I draw a tangent line to the curve at that x value, that tangent line is going to cross the x-axis eventually. And so that's going to give me a guess, an idea of where my function might cross. Now, it's not going to be where the function crossed. It's going to be an approximation, but it can give an idea. So then if you use that number and plug it back into the function and draw another tangent line and find where that crosses, well, that's going to give you another idea, another x value that's even closer to the zero. And if you repeat this process enough, you're eventually going to come to the zero. And so Newton has this formula here saying that x of n plus 1, so meaning like the second guess or third guess, fourth guess, whatever it may be, is equal to xn minus the function evaluated at xn divided by the derivative evaluated at xn. Okay, so for instance, to find the second guess, to find the second guess, you would have to take your first guess and plug it into the function, plug it into the derivative, find the ratio, subtract it from the first guess, and that will give you the second guess that you can plug back into this. Okay, now to do this by hand, it gets very cumbersome and it's a lot of calculation. So we're going to use the calculator to help do this for us. So let's take a look at an example. If we have x cubed plus 3x plus 1 and it's equal to 0, this is there's not a nice solution to this equation. All right, in fact, we can't factor it. We can't use any quadratic formula type thing because it's a cubic and it's not in a nice form that we can just solve this function. So we're going to use Newton's method to do this. So in order to do that, we need to know the function, which our function is just simply x cubed plus 3x plus 1, and our derivative of the function, f prime, is equal to 3x squared plus 3. All right, so Newton's method says that for any guess we make, say we pick some x value, and then we're going to subtract the function evaluated at that x value divided by the derivative of that function evaluated at that x value, and that's going to give us a closer guess to the zero. And if we keep doing this and keep plugging it in, we're going to eventually find the zero. So I'm going to show you how to do this on your calculator. So if you have a calculator, pull it out, and we're going to plug in these two functions that we have here into our y functions in the calculator. So if you turn your calculator on and go to the y equals, you'll be able to plug in functions. And y1 needs to be your original function, x cubed plus 3x plus 1. And y2 is going to be your derivative function, which in this case is 3x squared plus 3. So plug those into y2 and y1. If you need to pause the video to make sure you get those in, go ahead and do so. Then once you have those two plugged in, go back to the home screen. And remember, you can do that by hitting second and then quit, the button right next to the second button. And that takes us to the home screen. Now, we have to use this function called store, which is the STO button right above the on button down in the bottom left-hand corner. And what that does is it stores a value into a given variable. So we're just going to take a guess and say that we want to pick a number where we think that it's going to be a solution to this equation. So let's just pick 1. All right, we could pick 1, we could pick 10, we could pick 18. Doesn't matter what we want to pick. We could pick 0.3 if we want. Doesn't matter. Okay, and we're going to store that into X. Now, where did this arrow come from? That's right above the on button, the STO with the arrow. So we're telling the calculator that whenever we use X, we want it to equal a value of 1. So hit enter, and the calculator just confirms that yes, 1 is equal to 1, and that's what X is equal to. Okay, and you can always hit X and hit enter to see that, all right, the calculator's seen X is equal to 1. Now, what we want to do is we want to type in Newton's method here, okay? We want to type in X minus y1 divided by y2 because y1 is our function, y2 is our derivative function. Now, how do we get the y1 and y2 on our calculator? We want to hit this variable button, the VARS. It's right next to the clear button. If we hit that and then go over 1 to the y variables, and the first option is function, click on that, we can select y1. And then we want to divide by, hit the variable button again, go over 1 menu, select the first option, divide by y2. Why are we doing that? Because y1 is our original function, y2 is our derivative function. Now this is what you do for a TI-83 and a TI-84. If you have a TI-89, you're going to do this similarly, but you're going to have to manually type in y1 parentheses x divided by y1 parentheses, divided by y2 parentheses x. You'll have to manually type in all of that in order for this to come out the way you want. Now, what we want the calculator to do is once it does this, once it takes the ratio of the function and the derivative function at x equal to 1, and we subtract it from 1, we want to store that new answer back into X. So we hit the store button and hit X. And so when we hit enter, it gives us a value of 1/6 or 0.16 repeating. Okay, and if we were to do this by hand, we would get that same value. All right, now if we hit enter again, it gives us another value. That means that what we did is we took that 1/6, and now that is our new guess that we're plugging back into Newton's method, back into the function, into the derivative function, and we're subtracting it from 1/6. So we get a number of negative 0.321321321, and it repeats, so on and so forth. All right, well, let's hit enter again, and again, and again, and again, and again, and we notice now we're starting to repeat. So this must be our 0, negative 0.322185, okay? So our 0, x, is approximately negative 0.3222185. And if you check this is actually correct. If you plug that back into the original function, it'll give you 0. Now, it'll be approximate because this is an irrational number that goes on forever and it doesn't terminate, but that gives us an approximate answer.